and we're back with another Tuesday bulletin of engineering information for the radio and television trade. More on aerials today with the conclusion of our two-part feature. We visit an aerial factory to see how a design is optimised and then mass-produced on the shop floor. We've also our usual roundup of transmitter news, with Channel 4 arriving at more existing relays, and details of new stations at Durness in northern Scotland, Hales Owen in the West Midlands, Singleton in West Sussex, and South Brent in Devon.
Last week we took a brief look at how aerials work. The Yagi aerial is in everyday use throughout the world. With its dipole, reflector and directors, it can be designed to operate on a single channel or, with care, over a wide range of frequencies. But how's it done in practice? To find out, Bruce Randall visited an aerial factory and spoke to aerial designer Brian Hyde.
It seems, Brian, that aerial design is a bit of a black art, certainly a bit of a mysterious process. Is it actually scientific?
Yes, it is scientific. It's based on scientific principles. The best aerial for true scientific applications are the log periodic, where we can design it from first principles from tables. With the Yagi, if we want a wideband Yagi, like the one we have in front of us, we have to in fact do it by a certain amount of black art. This is normally carried out by starting at the dipole assembly here and the reflector, and you normally tune those up to get the best performance you can at the bottom end. You then tend probably to add the resonator here to see if you can get a start on the front, on the top higher frequencies, and then you start adding the directors one by one, gradually building up the frequency response across the whole of the band. This is the difficult part of it. You often find you can get it right at the bottom and you can't get it right at the top.
And the directors are added to give gain?
The directors are added to give gain.
They seem to be very irregularly spaced. Is all that part of the process?
That is all part of the process, and this is the part of the process which is the reason why you can't calculate it.
It's trial and error?
It's trial and error. Probably with a large enough computer one could, but we haven't got around to that, and our customers won't pay us enough for it.
So this little hole here is where
an example.
There's been an adjustment made?
Where an adjustment would be made.
What about this junction box? Is there anything special about it?
Yes, a complex aerial of this kind tends to have problems with its impedance, and therefore you normally use a balun in here to in fact correct it, and this balun is in fact mounted beneath this panel here, because working at high frequencies you need to hold it firmly in one place. It's important that this assembly here, in passing, should in fact be kept as waterproof as possible, because you do find problems with liquid and water vapour getting down the quad air type cables which are in use for this kind of application. So a nice smear of silicon grease on there is a useful thing to have.
This is the idea as boxes to get the maximum amount of signal out of the aerial and safely into the cable.
Yes, and to get as good a match as well, because you don't want to lose signal and you don't want to get trouble with teletext and things of that kind.
And when you've finished with all the trial and error, presumably you must test the aerial somewhere to make sure it's still working.
Yes, we have to mount it on our test pole and blow it up, and I'll just go and turn on the compressor and you can see it going up.
Outside, the aerial under test is mounted on a pump-up mast. Once raised to its maximum height, it picks up signals beamed up to it from a log periodic transmitting aerial just above roof level. Having previously calibrated the system with a receiving aerial of known characteristics, and being aware of the various feeder and transmission path losses, it's possible to measure the exact frequency response and gain of the aerial. The measurements are repeated many times, adjusting the length and spacing of each element of the aerial in turn. It's a long process. Only this way is it possible to be really sure of the overall effect on performance. And once the design has been finalised, the aerial can then go into production. But that's another story.
and a reminder of the importance of using the correct aerial group for good television reception. You can't necessarily tell the group of the aerial just by looking at it, but UHF aerials are usually coded by letters or colour, sometimes inside the junction box. Remember, there's usually no substitute for a quality aerial. You simply get what you pay for. Very good value indeed is a visit to Crawley Court, which can cost nothing at all. Members of the trade only, I'm afraid, but we've a few places left for our next organised visit this Thursday. But we'll need to hear from you today, so if you're interested, please ring Diana Cousins on Winchester 822 403 as soon as possible. That's Winchester 822 403.
Transmitter news now, starting with special announcements very briefly. Tomorrow morning there's to be an interruption to the Hemel Hempstead relay at Bedmond between 9:30 and 12:30. This is for aerial work. And in the Borders, Peebles is expected off until midday on Wednesday, Thursday and Friday for weather-dependent aerial maintenance. This will also affect Inner Leithen. Day-to-day transmitter information can be found in detail on Oracle page 697. By mid-morning we aim to get as much information as possible on the air about engineering work on that day.
New relays now, and in Devon the South Brent relay is on the air for about 500 people in South Brent itself, Brent Mill and Higher Turkley, as well as in Lutton, where we've just beamed an additional signal with horizontal polarisation. Viewers in the Lutton area using weak signals from Kingsbridge should have their aerials redirected towards the new relay and, if possible, minimise any pickup from Kingsbridge. Elsewhere, it's vertical polarisation, and with the channels being 43 and 50 for ITV and Channel 4 respectively, Group B aerials are needed. That's South Brent, now on the air with official service due this Friday.
Expected to begin transmissions this week, Hales Owen in the West Midlands. This relay is for about 800 people in southern outskirts of Hales Owen, including some but not all parts of Short Cross. Central and TV-AM will be on Channel 61 and Channel 4 on 54. Group CD aerials should be used vertically polarised. Hales Owen is expected on the air later this week.
Near Chichester in West